All right. So we're going to be simplifying. We're using all those trig identities we looked at yesterday. So first thing we're going to do is wait and listen.
Pardon this interruption. Teachers, please send your period 3 weeded testers to their testing rooms. Thank you.
I don't know that I had any in here this period, but that's okay. At least she was shorter this time. Sometimes you can tell when people are a little bit lonely in their offices because they just talk a long time. All right. Nope. I wanted this on that one. Okay. So on this one, first thing I noticed that we have two different fractions with two different denominators. And I don't like that. I'd like to be able to smush them together into one fraction so we can simplify. So what do I need to get them to have in order to be able to smush them together? Common denominator. So what do I need to multiply this one by for it? Yeah, cosine of theta over cosine. I can multiply it by 1. It's a weird looking 1, but it's a 1. What do we need to multiply this side by? Sine over sine. Sine of theta over sine of theta. So when we come down, and we can do this all in one, because honestly, we are super strong. We can do this. We're going to have that common denominator of cosine theta, sine theta, because we multiply these together. Then we're going to need to multiply cosine times this whole product here. Cosine times 1 plus sine. That's going to give us cosine of theta plus cosine theta times sine of theta. Right? And then we're adding that between the two fractions to our sine times this grouping here. Cotangent theta, sine theta. So we're going to have our cotangent sine minus cosine sine. Everyone see where all those pieces come from? It's a hot mess and it's big, but it's there. What do we notice in this numerator? You gotta be loud because I got the heater on right now because I know it's cold.
You can add the two things in the middle.
We can't add the two things in the middle because I've got cotangent here, which is different than cosine. What do you?
The cosine theta times sine theta. It cancels out with the other one.
Yeah, I've got a plus cosine sine minus cosine sine. So cosine sine, cosine sine. Since one is positive and one is negative, they cancel out. So what we're going to have now is we have cosine. I'm going to put that up a line just because we're in nice space. Our cosine theta. And now we have cotangent sine over cosine sine. Oh, I forgot my theta here. There we go. So now let's see if we can simplify stuff a little bit. So let's look at our cotangent sine, because that's kind of messy. How do I write cotangent in terms of sine and cosine? Because everybody else here is in terms of sine and cosine. It's the reciprocal of tangent, but let's do it as sines and cosines. It's 1 over tangent. So I'm going to write everything else out here real quick. I'm just going to put everything over here. Which will put us as cosine over sine. So I'm just going to write the whole thing over here. So we're going to have our cosine theta, and we're over our cosine theta sine theta. We're writing our cotangent. That's going to be our reciprocal of tangent. Remember, tangent is sine over cosine. So cotangent is cosine over sine. So cosine theta over sine theta times sine, right? That piece is still over here. What happens there? Our sines cancel out. Sine and sine. So I have cosine theta plus cosine theta. How can I simplify cosine theta plus cosine theta? So this is going to become 2 cosine theta over, did you say you can't see or something about going to sleep? If we can't see, I can adjust stuff. Sleepiness, I can't help. We're almost there. What else happens? Our cosines are going to cancel out. Everything's being multiplied, so I can cancel top and bottom. That's going to leave me with 2 over sine of theta. But I'd really like us to not have something in the denominator. Can we get it to be... You're thinking rationalizing, which is close but not quite right. What is the same thing as the reciprocal of sine? Sine goes with, which one? Cosecant. So this is the same thing as having 2 times cosecant of theta, because sine and cosecant are reciprocals of each other. So 1 over sine is the same thing as cosecant. So 2 times 1 over sine is the same thing as 2 times cosecant, which I actually have an error. Okay, so these are messy a lot of times, and sometimes they take up a lot of space, especially when we have like multiplying ekiness here. Or when I find an error in my book. This is fun. So this is our final answer here. Okay, questions on this one? There's a lot of stuff in here. A lot of stuff. Okay, let's do another more simplifying stuff. We're gonna just live in this world of simplifying for a while. So here's our next one. We have sine squared theta minus 1 over tangent theta sine theta minus tangent theta. So there's a lot of stuff happening here. So we're going to look at our numerator and our denominator kind of separately just to think about them. What do we notice about our numerator? It's got a sine squared in it, absolutely. So we can either see that and think back to our Pythagorean identities. There's absolutely a way through it in that same way. But in this case, I also see that I have subtraction in both of these. So I bet there's something involved that I'm going to be able to cancel out. So this is also a perfect square here and a perfect square here. It's a difference of perfect squares. So I can write this as sine theta plus 1 and sine theta minus 1 using that difference of squares pattern. We can still pull all that old factoring stuff in. What do we see in our denominator here that we could do? There's a tangent in both of these. I can factor a tangent out. So I can write this as tangent theta times what? What do we get when we factor out that tangent? Sine theta minus 1. So when we have subtraction in both of these, or if we have a sign in both of these, sometimes look at it like factoring. That'll help cancel stuff out. You can absolutely do it going the Pythagorean identity route, putting things in sines and cosines and canceling stuff out that way. It'll still work. It'll be messier, but it'll work. But this one works pretty well with factoring, because what happens here? Yeah, our sine minus 1 cancels out. And we are left with, let's see, I'm gonna put it over here just so we're really clear where things are. Sine theta plus 1 over tangent theta. And we know we're gonna try and switch things back into sine and cosine, so I'd really rather not have fractions of fractions. So what I'm gonna do is I'm actually gonna switch our tangent up to make it be multiplying. So I'm gonna rewrite this onto a single line as sine theta plus 1 times, and to get tangent up out of the denominator, it's the reciprocal cotangent. As I say, there are a gabillion ways through these problems. Like, I'm just showing you one of those ones that's, I think is this like the shortest. These kinds of problems, I'm not going to be saying, well, you took a different route than me, so wrong. There are an infinite number of ways to solve these. There are so many different ways through them. So if you're finding a pathway through, you're probably fine. On this one, what I'm gonna do is I really would like to be able to simplify this out and see if we've got sines, cosines places. So I'm gonna multiply these out and see if we can get anything to simplify. So I'm gonna rewrite this again as sine theta cotangent theta plus cotangent theta. Not forgetting my thetas. And then this guy, I can switch into sine and cosine to see if I can get anything to cancel out. I am fine with having a cotangent here. I just want to see if this guy will simplify. This one. So I'm going to rewrite that as sine theta times cotangent. How do we write cotangent in sines and cosines? It's cosine over sine. Cosine theta over sine theta. Our sines cancel out. So our final answer here, as simplified as we can go, is cosine theta plus cotangent theta. And that's as simplified as we can go. It's okay if they're still adding and subtracting. We would just like it to be as small as possible. So these are messy and weird and awkward, and they feel really long sometimes. And depending on the pathway you take, it could be a long problem. But there are many pathways through them. Like, sometimes they're just real long.
I have a question.
Yes, dear.
In the first step, how did you get tangent theta parentheses sine theta minus 1?
We factored out a tangent. Since there was a tangent here and a tangent here, I pulled it out like a greatest common factor. Just like if we had, think of this as, ooh, wrong pen, sorry. Think of this like 2x minus 2. When we would factor out a 2 to get this as 2x minus 1. Okay, so we're pulling out the tangent like that too. Okay? Good question.
Thank you.
Yeah, no problem. I am always happy to explain because sometimes my brain goes in weird directions or I don't know. My brain's weird. So if I ever need to re-explain my brain, 100% down for it. Okay. I'm going to put one up that's going to look scary. I promise it's okay. I told you it was going to look scary. Honestly, when we go through this one, I think you will want this one on the test. I told you, it looks scary. It looks scary. I promise this one's really, I got this one on one line in my book. There's a lot of letters though. There's a lot of things. We've got secant cubed theta minus cosecant cubed theta. And it's over this hot mess of a denominator that's secant squared theta plus secant theta cosecant theta plus cosecant squared theta. Gross. I promise you, you're looking at this one, you're just looking at it now, panicking, and it's really not that bad. Look at our numerator. That is a difference of cubes. Remember our difference of cubes? That's one of our special patterns. And when in doubt, always gonna wash it out with soap. Remember that guy? We have our same opposite, always positive when we factor things. Ah! Yeah, you did. Yeah, she did. She taught me that. So that was when we would have our like x cubed minus y cubed. And we could write it as x with the same sign minus y. And then our x squared opposite sign plus xy plus y cubed, or squared. That guy. Our difference of cubes or sum of cubes pattern. We can use that still here. So when I do that, which is going to make this look longer very briefly, we're going to get our secant theta with the same sign, so minus cosecant theta. Then we're going to have our secant squared theta plus secant theta cosecant theta plus cosecant squared theta. It's a lot of letters. And our denominator is our same hot mess of a thing. Our secant squared theta plus secant theta cosecant theta plus cosecant squared theta. And I know at least one person has noticed it, but this denominator exactly matches this piece here. So this whole hot mess cancels out with this whole hot mess. Told you this one was scary looking, but not awful. It's like, I'm never going to on purpose trick you. It will never be on purpose if it happens. I'm never going to do it on purpose. Okay? So, I never promise accidental. If there's accidental trickery, it's accidental. But I never will on purpose try and trick you. I do my best to make sure it doesn't happen accidentally, but I'm human, so I do my best. So we're left with just secant theta minus cosecant theta. Secant and cosecant are based off of different pieces. One's based off of sine, one's based off of cosine. There's not really anything we can do to simplify that. So that's the simplified answer. That's it. That's the end. I told you that one didn't suck too much. It's messy and it's big and it looks gross and it's scary. but it's not super duper long. Yes, sir.
On the one where you changed it to 2 cosecant beta, which one is the final answer?
Oh, on this one? So this should be our final answer. Okay. Questions on this one or any of the others we've done? We're good. Okay. So we are going to start working our way towards doing some more with we're going to put equal signs back in, but we're going to start with a weird that the IU listed in the types of problems they want us to do. They gave us a weird one, so we're going to do a weird one very much like it. So in one of the homework questions, it says to write one of our trig functions using only a different one. So we're going to define tangent using only cosines. So we usually write tangent as sine over cosine, but we're going to write it using just cosines, which is a little weird. But one of the homework problems, it's number 49. It's very similar kind of vibe to this. Okay, so question number 49 is a very similar vibe to this. It's different. It's using different trig functions, but we're doing kind of the same thing. So we want to write tangent using only cosines. So things we are going to need to have for this is we need to know what tangent is. And we usually write tangent as sine over cosine. So tangent is the same thing as sine theta over cosine theta. So what we need to have is something that tells us the relationship between sine and cosine. And what we have that puts sine and cosine in the same equation is those Pythagorean identities. We had our first one, which was sine squared theta plus cosine squared theta equals 1. That was one of those Pythagorean identities. And that tells us something about a relationship between sine and cosine here. So what we're going to do to be able to write tangent using only cosines is we're going to solve this guy to get a sine equals. I need to know what sine is using only cosines. We're going to do the whole thing, so not do it into our heads. So what can I do to this to try and get sine by itself? Subtract the cosine. Minus our cosine squared theta from both sides. That's going to give us sine squared theta equals 1 minus cosine squared theta. But I don't want sine squared. I want sine. Square root both sides. If I do the square root of this, if I unsquare sine, that's going to give me sine of theta. But whatever I do to the left side, I do to the right. It's a mess, but it's what they're looking for. And you picked this question, not me. I'm sorry. 1 minus cosine squared theta. It's a mess. And we're going to leave it like that. It's okay. So I can take this and substitute it in for sine. Yes, dear.
Is that not a difference?
It is a difference of squares, but that doesn't help us with square rooting because it would need to be a perfect square in order to be able to get rid of it. So if we were looking to try and factor this and simplify it, we could absolutely put it as a difference of squares. But since it's in a square root, it's not actually going to change anything for us, so we don't need to. Absolutely 100% fine if you want to write it like that. Totally cool. Doesn't actually change anything for us, though. So if we want to write tangent using just cosines for some reason, because that's a choice, genuinely, I have no idea what we would use. Like, it's one of those things that is just like a, okay, kind of thing. Not a thing we're going to use all that much. They're just wanting us to play with these like Play-Doh in a very specific and strange way. So our sine we can write as the square root of 1 minus cosine squared over cosine. Whoop. This guy? Which piece? The pink part? That's one of our Pythagorean identities from yesterday. When I was like, I don't have to slide up. Where we had our sine squared plus cosine squared equals 1, our 1 plus tangent squared equals secant squared, and our 1 plus cotangent squared equals cosecant squared. So this is one of the Pythagorean identities, and I'll just label that for us here. There we go. So this is a Pythagorean identity. This is one of those things. We need to work on memorizing these. We are going to need to know them. We're going to use them lots and lots and lots. But that's one of those Pythagorean identities. And then this piece down here, this is tangent written with only cosines. It's pretty much we're doing this just because Ivy said put it on the homework questions, which means the professor picked it who writes the final. And so if the professor who writes the final picks the question, I want to make sure we do one like it, just in case, because that's the person who writes the final. Okay? Yes, dear.
But he's not the one teaching us, though. You are.
No, but he's the one that gets to write the final.
That's unfair.
Well, it's because every IU pre-cal course takes the same final. So you will take the same final as Mrs. Glaze's DC class, as everyone who takes dual credit in every high school that partners with IU. Same with everyone who takes pre-cal on the IU campuses. Everybody takes the same final. So if the professor who writes the final picks the question, we're going to practice the question. Okay? So sometimes when we get a weird random question like this, that's what it is. This is one of those things that practically wise, we don't use this for much of anything. This is not something we need to memorize. This is not something we need to know that tangent is the same thing as the square root of 1 minus cosine squared over cosine. Not a thing we need to know. It's just a way of kind of practicing playing with the identities and getting comfortable with the identities is, I'm pretty sure, the goal behind it. But I don't get to talk to the professor easier with asking questions. So, I wanted to practice one because there was one like it on the homework because the professor picked it. Like, that's the thing behind it. Okay. So, from here, we're going to head into something called verifying. So now we're going to be verifying. So verifying just means we are not just simplifying anymore. Simplifying didn't have equal signs. Verifying has an equal sign. Our goal is still to not do a ton of crossing of the equal sign. If we have to do a little bit, that's okay. But our goal is to not be like back and forth and back and forth and back and forth. Try and simplify. It's very much like when we did our proving of the identities yesterday. Same kind of vibe. We're going to play with one side, trying to get things to cancel out. All that kind of jazz. Okay. So the first one we're doing here is tangent times cotangent. Ooh, it's fun. I don't have that one in my notebook. I love it. Okay, works. All right, so tangent theta times cotangent theta equals 1. And we're going to try and manipulate one side. I'm going to work with this side because that's way too many options for me. So let's work with this side. Tangent and cotangent. And again, I'm going to try putting them into sine and cosine and see if that helps figure stuff out. Tangent, we can write that as sine theta over cosine theta, right? No screen. Thank you. Goober. And then our cotangent, we can write that as cosine over sine. What happens? They cancel out. My cosines cancel, and my sines cancel. What are we left with? Just 1. So we get 1 equals 1. And we have verified it. My left-hand side matches my right-hand side. That's what we're trying to do. We're trying to get the left-hand side of the equal sign to match the right-hand side. And again, there's 2 or 3 different ways that I can see to go through one even this simple. We could put this as tangent theta and rewrite cotangent as 1 over tangent. It'll do the same thing. It'll still simplify down to 1. I could write tangent as the inverse of cotangent. They're reciprocals. I could do this in a number of ways. Okay? Love it. I don't know where I got this page from, but it's not in my notebook at all. Fun times. I'm making these 2 up as I go. All right, so we're going to be a very similar thing on this right-hand one. We're not necessarily trying to cross the equal sign as much as we can. We are just going to see if we can simplify. Right-hand side is cosine, which is fine. I could try and do things with that, but it's generally easiest when we're doing these verifyings to take the more complicated side and play with that. So just kind of as a starting place, pick whichever side looks grosser and try and make it less gross. So I can take my sine theta cotangent theta and try and write this using just sines and cosines. When in doubt, go sines and cosines. So sine of theta times our cotangent, which is again our reciprocal of tangent, yep, which is going to be our cosine of theta over sine of theta. Yeah, our sines cancel out, and we're just left with our cosine. And so we've gotten our left-hand side to match the right-hand side. And a lot of times when I'm doing this verifying stuff, I will not write both sides the whole time. Just, it keeps me in mind with my goals. Also, it's less work. So this is totally valid to do this, and especially when we look at some of them that are a little bit longer, not writing the right-hand side will save us some time and save us some effort and save us some hand cramps in our hand. Okay. Let's do some more. Yay, one that's in my book. Huzzah. Be like, I love when there's random problems that show up in the slides that I write that I didn't put in the book that I write. All right, so our next one here, very similar vibe. We've got sine theta secant theta times equals tangent theta. So sine theta secant theta, and we want to see if that equals tangent theta. So I'm going to switch these on the left-hand side to be sines and cosines so that we can see what's happening here. So sine already is in sines and cosines. How about you write secant as a sine or a cosine? Secant. 1 over cosine. Secant goes with cosine. Remember, each pair only gets 1 co. So cosecant goes with sine, and cosine goes with secant. 1 over cosine theta. Each pair only gets 1 co. Let's put this equal sign to help us remember that's the end of that line. So if I have sine of theta times 1 over cosine theta, what does that equal? I was going to say it's sine over cosine, right? What does sine over cosine stand for? Like if I put it back into regular trig functions, that's tangent. So that's tangent theta. And that's exactly what we were aiming for, tangent theta. So we did verify this. Ta-da. Once we get the left-hand side to match the right-hand side, we're done. I want the left side to match the right side. Let's see. Okay, let's do another one. Deep breath. It looks a little scary. I promise it's not bad. As I say, it looks a little icky, but I promise it's not awful. So we've got 1 plus sine of x times the quantity 1 minus sine of x equals 1 over secant squared x. And in this case, we might do a little bit on both sides of the equal sign, just because this guy is extra gross, but this side is also gross. So, so the left-hand side here, what can we do here? That is a wrong pen still. Yeah, I was gonna say, and you guys caught on to that. I love that. This is a difference of squares, and we're gonna multiply it out. So we'll have our 1 times 1, sine times 1, minus sine times 1, and our minus sine times sine. If you want to multiply the whole thing out and then simplify, that's totally valid. I'm going to write the whole thing out and then simplify just so we see it. So our 1 times 1 is 1, plus our 1 times sine of x, minus our 1 times sine of x. I don't know what that is. There we go. And then we're minus sine squared x. But we noticed here, as like most of y'all caught this, that this is a difference of squares, so these middle two terms cancel out, and we're left with our 1 minus sine squared x. So that's helpful for sure. The right-hand side, it's hard to know where to go from here because we don't know really what we're aiming for with the secant. Secant is one we're not as comfortable with. So we've got secant, and it's in the denominator, which is kind of gross. Can I rewrite this using sines or cosines? Secant is the same as 1 over cosine. So I could rewrite this as 1 over cosine squared, right? Because secant squared x is the same thing as 1 over cosine. So if I have 1 over cosine squared, I was like, we're not crossing equal signs. Just trying to keep it on the pink. Change the sign, flip. So 1 times cosine over 1. So this is just going to be our cosine squared x. So we can still play with both sides to make them be less gross, but we're not trying to cross signs. I don't want to multiply both sides by secant squared. You're going to make things super gross. I want to try and keep things on their same side and just flip as needed. Okay, because now I'm trying to relate sine and cosine. That is so much more familiar. Those are pieces we know way better. I've got a sine squared, I've got a cosine squared, and I'd really like to know their relationship. So we're going to pull up one of our Pythagorean identities. Sine theta, or sine squared theta plus cosine squared theta equals 1. And I'm going to I would like to manipulate this guy around to see if we can have it be equal to cosine squared. What can I do to this to make it match up 1 minus sine squared x? I was going to say, we can do that here. If we add sine squared x, it's going to make it line up exactly with this. That is absolutely one way through this. I could also say, well, if I subtract sine squared up here, we're going to have cosine squared equals 1 minus sine squared. That's totally fine. So again, there's several different ways through it. And just since you guys went that way, we can go ahead and add sine squared x to both sides. Not my instinct on this, but that's what, like, I heard that from a couple of people. To get our 1 equals cosine squared x plus sine squared x. Our other option is to come up here and have this be our cosine squared equals 1 minus sine squared. And substitute. What's up? What's up? Which part? This thing? It's Pythagorean identity again. That's the same one. Okay. Say it again. They're going to end with, yes, we verified. If it says verify, you're not going to come up with an answer. It's just going to be that we have a solution. So I'm going to post up here our announcement page that has the homework questions. It has a couple of modifications on here. Currently have it listed as 6-2B, being due on the 16th, which is tomorrow. We're going to do a little bit more verifying tomorrow. So let's make 6-2B due on Friday, which is going to push our quiz to next week. We are not doing quiz on Friday. See ya. We are not doing the quiz on Friday. We're doing the quiz next week. Okay? I will get you a review on Friday so you can use it over the long weekend.